As we continue to explore the periodic table, it's important to acknowledge the synthetic elements. These are the elements with atomic numbers higher than 92 because they are not found naturally on Earth. They are made by forcing nuclear particles to crash into one another. An example is plutonium. It is made by bombarding the nuclei of uranium-238 with neutrons in a nuclear reactor. Scientists use something called a particle accelerator, which moves atomic nuclei faster and faster until they've reached very high speeds, hoping that it crashes into the nuclei of another element and combines into a single nucleus. This is an example of a particle accelerator. You can see it uses a very long distance in order to allow those particles to gain the proper speed. An example is curium, which is abbreviated Cm. It was the first synthetic element to be made by colliding nuclei. There also are nonmetals, inert gases, and semimetals. Nonmetals are classified as elements lacking most of the properties of a metal. They are poor conductors of electric current and heat and are dull and brittle. Their physical properties include that 4 are gases at room temperature. All of the others are solid except for bromine, which is liquid at room temperature. This is also something that I won't hold you directly accountable for. The chemical properties are usually that they gain or share electrons, and when we come to chemical bonding, that's when we'll go into greater depth and I'll hold you accountable on an assessment. But nonmetals usually gain or share electrons when they react with other atoms. So for example, when they are reacting with metals, electrons move from the metal to the nonmetal. So if we've got sodium and chlorine, when they bond, they create sodium chloride. The metal usually leaves or loses 1 electron to the nonmetal chlorine. And that's how we make salt. It can also form compounds with other nonmetals by sharing electrons, bonding them into molecules. This is called covalent bonding, and we'll discuss this in a later chapter. Nonmetals are classified into families. They're classified into families based upon the element that it is at the top of their group. The carbon family is group 14. Each element has atoms that can gain, lose, or share 4 electrons. The nitrogen family is group 15. They usually gain or share 3 electrons when reacting with other elements. Next, we have the oxygen family. They usually gain or share 2 electrons when reacting with other elements. And I'll give you the hint as to how you can figure this out, again, in a later chapter. Finally, we have the halogen family, which is group 17. They usually gain or share 1 electron when they react with other elements. And it, instead of the others having the name of its family be the top element, here the top element is fluorine, but all of these are considered halogen. We also need to discuss the inert gases. That's group 18. These do not ordinarily form compounds because they do not usually gain, lose, or share electrons. They're also known as noble gases. Examples of them include helium in a balloon and neon in our glowing electric lights. Hydrogen is special because its chemical properties differ so much from other elements it cannot be grouped into a family. It actually makes up more than 90% of the atoms that exist in the universe, but it's rarely found on Earth as a pure element. Semimetals are special because they have some properties of metal, but they also have properties that are typical of nonmetals. All of them are solids at room temperature. They are brittle, hard, and somewhat reactive. A type of semimetal are semiconductors. They are interesting because they're substances that can conduct electric current under some conditions, but not under others. And so they're important for many purposes, including the use of silicon in a computer chip. It's important for there to be conditions where they conduct electricity and where they don't, and an example of a computer chip is the perfect one to explore when learning about semiconductors.